Hey guys, today I will be introducing a new species, the sandbox turtle. We will find out if the sandbox turtle population fit under the Hardy-Weinberg law. This law states that allele and genotypic frequencies will remain at equilibrium after one generation of random mating occurs. At this equilibrium, we have an equation to solve, but I will get to that in a minute. Let's meet our sandbox turtles. So, the black sandbox turtles with a square on their backs have the genotype SS. We also have a red sandbox turtle with a circle on its back. Lastly, we have a blue sandbox turtle with a triangle on its back. We have 40 turtles total, 12 with the genotype SS, 19 with the genotype ST, and 9 with the genotype TT. First, we need to calculate how frequent the alleles occur in the population. You can find this by dividing the total number of S alleles by the total number of alleles. For the S allele, since there are two genotypes with the S allele, you must multiply the 12 SS population by 2, then add the number of ST turtles, which is 19. Then divide it by 40 times the number 2, because there are two total alleles. Then we have 0.5375. Next, we do the same thing with the number of T alleles in the numerator, and we get 0.4625. These two numbers should always equal 1. Both of the numbers in your gametic array, or the set of allele frequencies. Next, we can calculate genotypic frequencies of the sandbox turtles. For this, just take the number of turtles with said genotype and divide by the total number. For example, if there are 12 turtles with the SS genotype out of 40, so you divide the 2 and you get 0.3. For the ST genotype, you have 19 out of 40, and for the TT genotype, you have 9 out of 40. The total of these numbers should also equal 1. Now you have your genotypic array as shown. Equilibrium equation is p squared plus 2pq plus q squared. P and q are gametic array values from earlier, so 0.5375 is p and 0.4625 is q. When you plug this in, you get 0.2289 for SS, 0.4972 for ST, and 0.4625 for TT. We can test to see if our prediction is correct about the turtles falling under Hardy-Weinberg's law by performing a chi-square test. Creating this table, I show how to calculate each column. If the value is less than 3.84, our prediction is right. So it just so happens that the SS turtles really like the TT turtles because of the combination of shapes making a 2D house. This idea violates the Hardy-Weinberg law because of such selection. This is known as underdominance. Our fitness numbers will be 1 for the SS genotype, 0.2 for the ST, and 0.8 for the TT phenotype. We will use the equation used earlier. Let's reference this table. Multiply initial frequency and fitness, then add up your unadjusted survivors for the average fitness. Divide the adjusted survivor value by the average fitness. Note that the value in relative frequency increased in SS and TT genotype and decreased in the ST genotype. Based on this, it's concluded that the SS and TT turtles will have a higher survival rate in future generations.